operating system provides the interface between the hardware and the user, right? Okay, in the evolution of operating system, first we are going to discuss about mainframe system. There are many evolutions in that. The first operating systems are used in mainframe system. In the mainframe system itself, there are three types: batch system, multi-programmed system, and time-sharing system. Okay, already we have discussed about this mainframe system, batch system, multi-programmed system, and time-sharing system. Okay, in the batch system, in which the computers or systems are in very enormous size, that is, it occupies a room size computers are used, in which the input devices are, what are the input devices used in early computers? Not keyboard. Punch card, tape drives. Okay, punch cards and tape drives are used as input devices, and output devices are line printers and tape drives. Okay. So in these batch systems, if the user want to do any operation, they need to write a job first. A job means it consists of program, data, as well as control information that represent the nature of the operation. So that job can be given in the form of punch card. That punch card consists of, punch card represents a particular job, and each and every job will consist of program, data, as well as control information. Control information that represents nature of the particular job or particular task. So this job can be submitted to the computer operator. That is, the user cannot interact directly with the computer. In the early computers, the user will submit the job to the computer operator. They will submit feed that particular job in that computer. The output can be received, cannot received quickly. It takes more than an hour, or sometimes it can take 1 day also. Because the user, in the early computer, the user cannot get the output for the particular task quickly. It takes more time, it may be more than an hour, or it takes 1 day also. Then here, if the user want to submit more jobs, that is also possible. They can able to submit more jobs. In that, many jobs, the computer operator will group the similar jobs together. If 10 jobs are submitted by the user means, they will analyze all the jobs. In that, similar jobs are grouped as a batch, and these similar jobs can be executed simultaneously in order to increase the performance. Okay. So in the early computers, it is having the main memory can have this operating system can show. Then the user can submit the job. The jobs can be loaded into memory. If job 1, job 2, job 3 are similar job means all the similar jobs can be loaded in the memory simultaneously to improve the performance. Okay. So in the batch system, it takes more time for providing output. Okay, that is the disadvantage. Then second system is multi-programmed system. In the multi-programmed system, there is many programs can be executed simultaneously. The programs that are ready to be executed can be initially placed in a job pool. There is some job pool. In this job pool, the processes that are ready to be executed are placed P1, P2, P3, P4, etc. up to Pn. Okay, there are n number of jobs can be placed in the job pool. Okay, and in these set of job pools, only limited classes or limited programs can only be stored in the main memory. Why? Why we can store only limited programs in memory? Because the main memory size is less. So we cannot store all the classes or all the programs in main memory for execution. We can, it is possible to load only limited number of classes or limited number of programs in main memory according to the size or free space available in the main memory. Suppose the main memory is having free space of storing only 3 classes, means 3 processes can be stored in the main memory. After completing all the or after executing the 3 processes or 3 tasks, then the remaining process can be occupied in the main memory for execution. Can you understand this? So this the process of choosing which program or which classes to be placed in the main memory is performed by the operating system. That process is called as job scheduling. Job scheduling, or we can say it as process scheduling. Okay, that is in second unit you are going to study in detail about this job scheduling. That is based on some criteria. It will select our operating system will decide which process to be placed in main memory. That is sometimes the process with less response time can be placed in main memory. Sometimes the process that comes that is based on FCFS, first come, first serve. Okay, the process which comes first can be placed in the memory first. Okay, so there are some priority based also. The process which is having more priority can be placed in the main memory first. Okay, so if there are many processes are available for execution, all the processes are initially stored in the job pool. From the job pool, the operating system can load some of the process in the main memory for execution, because in main memory size is very less. It cannot store all the processes simultaneously in main memory. So according to the storage available in the main memory, the operating system will select some of the processes from the job pool and store all these processes in the main memory. Okay, so the process of deciding which process to be placed in the main memory is based on the scheduling process. Scheduling represents that of selecting the process based on the response time. Some criteria are used based on the response time. That is, process which is having less response time can be placed in the memory. That is called as SJF. SJF means shortest job first. Okay, shortest job first. The process which is having less response time can be placed in memory. Some operating system can choose this scheduling. That is, first come, first serve. The process which comes first can be placed in memory first. Okay. Then in some operating system can use priority based job scheduling. The process which is having higher priority can be placed in main memory first. Understand? So in the multi-programming environment, it is possible to execute more than one process in the memory at the same time. That is, to improve the CPU utilization or processor utilization, it is possible to execute more than one process simultaneously. And the task of operating system is deciding which process to be placed in the main memory first. That is based on the job scheduling. Then third type of maintenance system is time sharing. Here, in this disadvantage of multi-programmed operating system, here multi-programmed system, the user cannot involve directly. That is, the user cannot give input directly. There is no interaction between the operating system and the user. Already we are giving the input in the program itself. We cannot give the input through the keyboard or mouse. Okay, Here, time sharing system can provide interaction between the program and the user. That is, user can provide the input through the keyboard as well as mouse, or using any peripheral devices or any I/O devices. The user can able to give input. So that is the difference between time sharing system and multi-program system. This time sharing system is also called as multitasking system. Okay. Then there is also one concept is used in time sharing system. Virtual memory. You know what is virtual memory? Virtual memory. Okay, secondary memory. Secondary memory means disk memory, right? What about virtual memory? Cloud storage. Okay. Okay. Suppose if the program size is very high, that is the complete program cannot be stored in the main memory means only some part of program can be stored in the main memory. The remaining part of the program stored in disk memory or secondary memory, right? That is, if you want to execute any program, the complete program needs to be loaded into memory, but the memory size is very less. We cannot store the complete program in the main memory. Okay? So in that case, only some part of the particular program P1 is loaded into memory, and the remaining part of the program can be stored in some secondary memory, some disk memory. This disk memory, the remaining part of the program P1 can be stored. Okay. After completing the core segment that are stored in memory, then it will get it will remove this part of the program from the memory, and the remaining part of the same program is swapped from secondary memory to main memory. Understand? If the main memory is not having enough space for holding the complete program, in that case, the remaining portion of the program can be stored in any secondary memory like this memory. And if the program loaded in main memory is executed, it completes its execution. After that, this can be removed from the main memory, and the remaining portion stored in the secondary memory will be swapped to will be moved to the main memory for execution. This process is called as swapping. Okay. Suppose the secondary memory is also not having enough memory for holding your program, means in that case virtual memory concept is used. Okay. Only the programs that are stored in the space available in the main memory can contain some core segment. The remaining core segment will be stored in the virtual memory. Okay. So the time sharing system, if there is not enough space in main memory for execution, then the remaining content of the program can be stored in secondary memory as well as virtual memory. Okay. So these are the three types of mainframe system. First one is batch system, second one is multi-program system, and the third one is time sharing system. Okay. Next we are going to discuss about the second type of system, desktop system. The next type of system is desktop system. The desktop system means it can be used by individual user. We can say the PC, personal computer. Okay. In the previous mainframe system, it cannot be used by individual user, but desktop system means it can be used by individual user, and the user can able to provide input through the keyboard or mouse. So user can directly interact with the program, and it is mainly designed for maximizing user convenience and responsiveness. Okay, the desktop systems are designed mainly for maximizing user convenience and responsiveness. That is, the previous systems are developed for providing only improving the CPU utilization and I/O devices utilization. But here, this type of desktop system or personal computers are mainly designed for maximizing the user convenience and the responsiveness. That is, in the previous type system, mainframe systems cannot be used by individual users, right? So there is no convenience for user. The user cannot do their program by own. But here, the main aim of desktop system or personal computer is maximizing user convenience and responsiveness. But previous systems are designed by maximizing CPU utilization. How CPU utilization is maximized? How the CPU utilization is maximized? Interrupt. That is when some I/O programs are executed, at that time CPU becomes idle. So to avoid that, some interrupt signals are provided in order to make the CPU is always busy in executing some other user program. So the previous systems are designed for improving the CPU utilization as well as peripheral. Peripheral means I/O devices. I/O devices utilization. Here, desktop systems are mainly designed for improving the user convenience and responsiveness. Okay, example for operating systems that provides this user convenience and responsiveness is Windows, Microsoft Windows, and Apple Macintosh. Okay, these are the example operating systems that provides this user convenience. Then here it uses protected memory. Memory can be protected as well as file can be protected by providing the permissions, read permissions, write permissions, and execute permissions. By providing the file permissions, it can protect the file stored in the system. That is but the disadvantage of this desktop system is it provides threat for worm and virus because of malicious program. That is, the desktop system or personal computer can be used by any number of users, right? Because of using the same system by many users, there is a threat for worm or virus. So that worm or virus can be spread to other system through the network, right? If the personal computer or desktop system is connected through desktop system. Okay. So desktop systems are designed in the year 1970. These desktop systems are personal computers are designed. The main aim of desktop system is for improving the user convenience and responsiveness rather than improving CPU utilization and peripheral utilization. Peripheral means IO device. And example operating system for providing this user convenience and responsiveness is Microsoft Windows operating system and Apple Macintosh operating system. And here it provides some protection mechanism for memory as well as files. Okay, the files that are stored in the system can be protected by providing read permission, write permission and execute permission. That is, if the user is providing read permission for any file, means that becomes read only. The other user cannot modify it. Okay. All the files stored are protected by providing the protection permission. But here the disadvantage is because of using the same system by many persons or many users can use the system. There is some possibility of malicious software. That malicious software can be spread as a worm or virus. That virus can be spread to other systems through the network. If many systems are connected to a system bus or if it is connected by a LAN connection, then there is a threat for spreading those virus among all the computers connected in the network, right? So this is the disadvantage of desktop system. Can you understand? Can you understand up to this? Okay. Okay, next system is, third type of system is multi-processor. Already we have studied about multi-processor system. Anyone remember multi-processor system? Multi-processor system. Multi-processor system. What is multi-processor system? Multiple processors can be connected through a system bus, and all the processors connected can share a common memory as well as they can use the common IO devices also. Okay, so multi-processor system in which it is possible to connect more than one processor. We can able to connect more than one processors through the system bus. Okay, more than one processors can be connected through the system bus, and all the processors can share a common memory. In multi-processor system, we can have number of processors, and all these processors can be connected to a system bus, and all the processors can share a common memory as well as it can use common IO devices also. So what is the purpose of having multi-processor system? What is the advantage? What is the advantage of having multi-processor system instead of single processor system? It can, its performance can be increased. That is, if you use 5 processors instead of a single processor, the can be completed within less time. Within less time, your process can be completed. So to improve the performance, they are using this multi-processor system. Okay, in this multi-processor system, there are two types. One is symmetric multiprocessing and another one is asymmetric multiprocessing system. There are two types of multiprocessing system: symmetric multiprocessing system and asymmetric multiprocessing system. So already you have studied about symmetric multiprocessing, right? Anyone remember what is symmetric multiprocessing? Symmetric multiprocessing system, SMP, symmetric multiprocessing system and asymmetric multiprocessing system. So what is that symmetric multiprocessing? Okay, symmetric multiprocessing system, all the processes connected in the system can perform the similar task. Okay, all the processes connected to the system bus can perform similar task in symmetric multiprocessing system, symmetric multiprocessor. But asymmetric means here all the systems won't perform the same operations. It acts as a master-slave relationship. In asymmetric, it acts as a master-slave relationship, in which one system or one node can act as a master, and that master can give job to other systems connected in the network. Okay. So in symmetric multiprocessor system, all the CPUs connected in the network or all the processes connected in the network can perform the same type of operation. But in asymmetric multiprocessing, one node or one processor can act as a master and the remaining all the processes can act as slaves. So that master processor can assign job to each and every slave processor. So here the master will not assign the same type of task to all the processors. They can assign different type of job or different type of task can be assigned to all the slaves. Understand this? So there are two types of multiprocessor system: symmetric multiprocessor system and asymmetric. Okay? In symmetric multiprocessor system, all the processes are performing similar tasks. Okay? So if one processor connected in the network fail means the remaining processor can share the work of the failed processor. Okay? In asymmetric multiprocessing system, all the processors cannot perform the same operation because here it acts as a master-slave relationship in which only one node acts as a master and the remaining nodes can be act as a remaining processes can be a slave. Okay? So the master node can assign job to all the slaves. So master is a processor which can assign tasks to all the slaves. So all the slaves can perform the instructions or tasks given by the master. Okay? This is asymmetric multiprocessing. Then what are the advantages of this multiprocessor system? Already we have discussed. What are the advantages? Refer your note. What are the advantages of multiprocessor system? First, performance can be increased. So increased performance Kamaleshwar, can you tell how the performance can be increased in the case of multi-processor system? So, because we are having more number of processors connected in the network, so instead of performing the same task by using a single processor, here we are using large collection of processors. So automatically performance can be increased. And if you want to include more number of nodes, initially it is having only 5 CPUs in the system, and if you want to add more number of nodes in the system, that is also possible. So increased performance. Then second advantage is economy of scale. Economy. Okay, how the economy can be increased? Okay, here all the processors will share a common memory, right? If you have multiple single processor, means each and every single processor will have separate memory. Okay, but here in the symmetric or in the multi-processor system, all the processors can share a common memory. So, or it can share a common peripheral devices, or it can share a common power supply. Okay, so in the multi-processor system, all the processors connected in the network can share a common memory, common peripherals, and common power supply. So that economy can be increased in the case of multi-processor system. Then another one advantage is increased reliability or increased availability. Increased availability. Okay, how the availability is increased? How can you say the multi-processor system can increase the availability? Yes. Okay, assume that you are having 10 processors in the multi-processor system. You are having 10 processors. Okay. In that 10 processor, one processor fails. In that 10 processor, one processor fails means what happens? The task of failed processor can be shared by the remaining 9 processors in the system. So if you have 10 processors in the multi-processor system, and any one of the processor fails, means it won't halt the system or it won't shut down the system. The task of failed processor can be shared by the remaining processor in the system. But here the only disadvantage is the performance is somewhat decreased. That is, performance is 10% slower than the previous one because of failure of single processor. Understand? So 10 processor இருக்கு, அதுல ஒரு processor fail ஆனா fail ஆன processor ஓட task remaining 9 processor பண்ணும். So இதுல என்ன disadvantage? Performance somewhat reduce ஆகும். It won't halt the system entirely, just it reduces the performance by only 10%. 10% of performance is reduced compared with the previous one. So it improves availability. Availability is increased in the case of multi-processor system. So these three are the advantages of multi-processor system. It can improve the performance. It can improve the economy. Because the economy is because of sharing the common memory. It won't take more money. But in the case of multiple single processor, each and every single processor will use separate memory, so it takes more money, right? But here all the processor can use same memory, same peripheral devices, and the same power supply. So it can able to improve the economy. And the last one is increased availability. Availability can be increased by that is if one processor fails means the task of failed processor can be shared by the remaining processor in the system. So this can also be called as fault tolerant. We can say this multiprocessor is fault tolerant. Fault tolerant. We can say this multiprocessor system as fault tolerant system because if one processor fails means the tasks that are performed by the failed processor can be shared by the remaining processors connected in the network. So this is called as fault tolerant. Do we know any other advantages of multi-processor system? Other than these three advantages, anyone know? So the multiprocessor system is having these advantages such as it can improve or increase the performance, and it can improve the economy by sharing the common memory, common I/O devices, and the common power supply, and it can also increase availability. Okay, availability can be increased. And one more advantage.
And how many kinds of things? All of you are having to do. Hereafter, I will make collect my on the spot technology. Very good. Give it there.
And one more advantage of this multi-processor system is scalability. That is, many systems are, many CPUs are interconnected with the system, and all the processors will perform similar operations, and it can have different pricing policies as well as different performance. So the systems that are interconnected in this multi-processor system can have different prices as well as different performance. That is called as scalability.